Nowadays, I'm more known for my work on LLM as a judge, in particular, all the million ways in which it fails, even though superficially it looks good. But then if you look closely, you see, and then you start thinking about, and you're like, oh, there could be like this issue and this issue and that issue. So that's something I'm a little bit like known for. Some people call me an LLM as a judge skeptic, which is absolutely not true. But I am somebody, maybe I'm a good engineer, and that I want to know what works and what does not work.
Welcome, Laura. Thank you for coming on the podcast. Great to have you here. Could you take a couple of minutes to introduce yourself and explain a little bit about who you are, what you do, and what your research is, please?
I'm Laura Dietz. I'm a professor of computer science at the University of New Hampshire. As you can hear, I'm originally from Germany. I now live here. My journey is a little bit like non-traditional. You know, I always felt like people who become professors were like, wake up one day and say, I want to be a professor. I was not that kind of person. People said, Laura, you should be a professor. I said, nah, I'm not going to be a professor. Laura, no, really, Laura, I think you should be a professor. No, I really don't think that's for me. And then I one day woke up and said, I want to be a professor. And I applied, and practicing being on the job talk, I kind of got a job in a location I wanted to be in, and I accepted the job offer. So yeah, but it's kind of like a typical thing for me. Like, I was the same thing with the PhD. I always wanted to do computer science. That was like a thing I was never wavering about. I like computer science. I also like design, but I figured computer science, that's more of a job. And yeah. Originally, I started in computer supported cooperative work. Like, how do people work together with the computer? And then somehow I kind of like was looking for a challenge, and I thought, I tried quality assurance, requirements engineering, project management, all that kind of thing. And it stopped being a challenge after a few months. And I was like, well, I was 26 at the time. So I want to have a real challenge. And then somebody invited us to a reading group in machine learning. And I didn't know much about machine learning at the time, except that it was really difficult. So I was like, well, that's going to be a challenge. It's also going to be an embarrassment. It turned out I was pretty good at it, and I liked it. And that kind of got me into a PhD that was more in a machine learning group. And towards the end of my PhD, I was a little bit like frustrated with how NERPS kind of like decides what's good research, what's bad research, and that it was very narrow. And I was like, I want to solve problems, and I want to solve big problems. So I started working on information retrieval, which was at the time more, Google web search kind of things. But like, I always came from it as a perspective of a machine learner, but also as somebody who wants to solve big problems and who's not afraid to code. Like, I know some professors are like, oh, I haven't coded in like decades. And I was like, you cannot be an artist that cannot know how to sculpt. You kind of have to be in it. And sometimes you just like need to force yourself to get your hands dirty. Otherwise, like, what kind of a computer science professor are you? You kind of like, you still live in the era where, I don't know, Python was an interpreted language or something, right? So it's kind of like, you just like lose touch with what's the craft, and that's not a good thing. So I like to think I'm a better person than that. So yeah, so that's kind of that was a weird introduction. Nowadays, I'm more known for my work on LLM as a judge, in particular, all the million ways in which it fails, even though superficially it looks good. But then if you look closely, you see, and then you start thinking about, and you're like, oh, there could be like this issue and this issue and that issue. So that's something I'm a little bit like known for. Some people call me an LLM as a judge skeptic, which is absolutely not true. But I am somebody, maybe I'm a good engineer, and that I want to know what works and what does not work. And if something does not work, then I would like to know about this sooner than later. I don't want numbers that I can measure that ultimately lie to me. I want numbers that say, hey, if that number is high, that's a good system. If the number is low, Laura, you got to do more work.
Wow, there's a lot to unpack there. So, yeah, I mean, my image of a university professor is very much that stereotypical one that you get in British television, where you've got an elderly gentleman with leather elbow patches stuck in the library at somewhere like Cambridge and Oxford, drawing on chalk.
I have elbow patches. Do you want to do them?
I have got very much that Goodbye Mr. Chips feel from anyone that remembers that TV show. But my university professors were definitely very much the same. They hadn't coded for years. used to drawing things out on a blackboard, which might suggest something about how old I am. So yeah, it's nice to hear the focus on coding and actually still applying the knowledge. And as you say, sculpting. LLM as a judge, and you say you're a skeptic. I like that because I try and position myself as both a fan of AI and a skeptic. So let's dig into that a little bit. First off, what is LLM as a judge?
Okay. The first question is, what are we judging? Okay. So, and there's like, and the short answer is, well, anything, any application that you could write with the help of, or like of anything, with LLMs or without LLMs, it would like produce an answer. Now you want to know, does the system produce answers that are actually good? So a lot of people look at this from a perspective of question answering. Okay. Mm-hmm. I look at it more from a perspective of like retrieval, or like maybe more like old fashioned was 3 years ago. Old fashioned like ad hoc search is like you just have a search bar, you pop in some words and out come a ranking. Is that ranking good or is that ranking not good? Nowadays, and that's like what was always what I wanted to do, was like what's nowadays called retrieval augmented generation, where you have a piece of software that reads the internet for you. And when you have a question, it kind of customizes the response for who you are, exactly the question that you were asking. And it's like really more like custom tailored to what the user wanted. I mean, that's something I've been working on that for the last decade. The thing what stopped me a decade ago to directly invent all the things that we are nowadays using was I did not know how to measure whether my imaginary retrieval augmented generation system was actually good or not. How do we do the evaluation with web search traditionally? Well, you hire some people, you pay them good money, top dollar or top pound, and you kind of like say, hey, for this particular query, when does the sun set today, or how high is the Eiffel Tower, and so on. I have retrieved this document. Is that document relevant? Yes, no. Or if it's relevant, how much? Played with like different grading scales and so on and so forth. But you always need to have like a human that says, this document relevant, this document not relevant, this document, and you do this for one query. You do this probably for like 500 documents. I do not want that job. I'd rather like to be a professor. It's like really, it's really hard. And it's also very expensive because, not many people want to do that job. For a while we had like Amazon Mechanical Turk or something. Turns out those people, if you pay them pennies, they still don't really want the job. So you get like a mix of low grade judges that you pay pennies for, or like high grade judgments that you pay a lot of money for. But if you don't have a lot of money to give to either of those people, how do you know what's relevant, what's not relevant? And if you don't know what's really relevant, you don't know whether your system retrieves the stuff that's really relevant. Sorry, I can sense a question from your side.
Well, I was going to say, if you're doing it at the sheer scale that somebody like Google will do for the search results, it's going to be phenomenally expensive to do that across even quarter of a percent of all the web searches.
Yeah, I mean, like, the big search engine companies, they kept people on the payroll to just manage this. And especially like when there's like new trends, like, people like I still grew up in the era of like 3 keyword queries for searches. Now I date myself. Now we have like more whole sentences, and now we have, with all the, like chat agents, it's all kind of like more free text, right? So the way in which we ask questions is changing. And also like our expectation of what we should be getting from the product also changes. We now have much higher bar than we had in the mid-90s. In the mid-90s, you were happy if you found one document that was somewhat relevant. Now people are like, well, why am I going to this search engine? It's like not very good. So we're talking about how do we, like, what's LLM as a judge? So now we just talked about the thing that we want to judge. Let's say in the simplest case, how good our search engine is. The part that's most cost intensive in how to judge how good our search engine is to look at every document that was retrieved and get a measure of how relevant it is. Once we have that, the rest is really easy. There are kind of a bunch of different measures, like normalized cumulative gain or mean average precision. They are all kind of like means of saying, in a ranking, do you have all the good stuff on the top and all the bad stuff at the bottom? The more that is true, the higher the metric, and then, the better the search system is. This is like ultimately what we want. And then, like bells and whistles, like, do we stop after the top 10 because, people will not move to the next site and so on and so forth. But this is roughly the idea. But the really expensive part is the manual kind of judgments. So I remember, like, there was GPT-3, and I remember, I think, like, some newspapers wrote big articles about it, like the future is here and everything. And people played with it, and I was like, yeah, it's a nice toy. It does something cute, but it's not really a thing, right? I mean, that's like how Code AI was maybe half a year ago. It's like, oh, that's a cute little thing. And now we're like, oh, this stuff actually works, right? It like does something useful. And that was kind of like, I think it was like end of 2023 when ChatGPT with what we all call GPT 3.5 Turbo kind of like hit the market, and people were like, oh man, that kind of like actually is something that I could see myself using for what I want to know, right? And I think pretty much like I was at Dagstuhl, which is like a famous center where researchers get together to think about like what should we do in the future. And I say, hey, we have that new thing, but why don't we play with it here? We have like all the people of the world that kind of like know how to, that you would want in a room to play around with that. Why don't we do this right here? So we wrote a paper called Perspectives on, I forgot like how, like LLM as a judge, and the paper got rejected, of course. But like at some point, like people saw the light, and what did we do? Well, we kind of like used an LLM and say, can that LLM produce relevant judgments? I mean, the second thought was, well, that's probably problems with this approach. Like I wouldn't call it dumb, but I'm like, the issues with this approach are kind of obvious, and I can spend the next 3 hours talking about these issues. But the idea was very simple. It's like, well, we have a human that says, here's a query, here's a document, is this relevant? Yes, no. And we just take that and say, hey, ChatGPT, is this query, this document relevant? What do you think? And what we found pretty much instantly is like, oh, actually, it does kind of correlate pretty well with what humans want. When I say now, I said correlate, so there are actually two different ways to measure how well would an LLM judge agree with a human. One is you look at the label level. You say, hey, a human thought this document is relevant. Does the LM also think that document is relevant? And if it's relevant, how much? Do they agree? Do they not agree on that level per document? The other question you can ask is, like, why do we even care about knowing how good a search system is? So we pick the best one, or we know which ideas that in the search system are kind of like the best one to pick. So you can sort of like take different search systems, and you can use these, usually we use these relevance annotations to identify which one is the best system, which one is the second best system, which one is the third best system, and which one is the system you never want to use. So once you have these LLM judges, you can do the same thing. So you can get like two, I would call them leaderboards of search engines. And you can ask, do they put the same system on top? Do they put the same system on rank 2? Do they put the same system on rank 3? And the more that's aligned, that's good. The more you have like system flips, you kind of like subtract some points. This is what, people call Kendall's tau. Or you can ask, is the same system that's on rank 2 here, is it still on the same rank here, or how far is the rank off? That's called Spearman's rank correlation. So it's like 2 means or 3 means to evaluate whether an LLM as a judge would agree with a human as a judge. These days, you need to point out that the judge is a human. So, and I think, and this agreement kind of like was, I mean, it wasn't 100%, but it looked like good enough. And that like reminded me of some work that I had done a couple of years before that, not with LLMs, but with a similar kind of idea where we tried a different way to evaluate like search result, like every document, by creating a multiple choice test that was designed for fifth graders questions. AI2 put out a data set. I happened to run a challenge that happened to borrow some of their queries. And then I had these questions that came with the data set, and we didn't really use them. I was like, hey, could we just use these questions to actually evaluate the IR systems? And because it was an exam, we called it the exam answerability metric, which is like Pine is not Elm. It's like exam answerability metric. Mm-hmm. Do you have a little bing symbol? So it's kind of like, and that was another thing where like, I did not really expect this to work. I was just like curious, is it like something that you can use? And it turned out it correlated really well. I was working with somebody, he wasn't even technically my student. We were just like working together, and I was like, go back, find the bug. These results are too good. I don't believe them. Go back, find the bug. So we come through it, and it was real. And I was like, okay, let me re-implement what you did. And that was not with LM. That was just with the question answering system that we had before. And I was like, Yeah, there is something here. Again, paper got rejected, paper got rejected, paper got ignored, paper got ignored. And at some point with LLMs, people are now, yeah, that was actually what we did back then is what we do now. It's just, as you call it, nugget-based evaluations in LLM as a judge. So I just re-implemented this at some point, got the best paper award as like our biggest company, biggest conference. And I was like, well, I was just re-implementing something that we did like 4 years earlier that you rejected. Okay, here we are. I guess
You're ahead of your time, perhaps.
being before the hype curve is not a fun place to be. All right,
So
anyway.
I immediately jumped to a question on that then. It immediately strikes me that evaluating search results is hard because there's not just what somebody wrote, but there's what did they mean. And as you say, there are an awful lot of people who go to Google or search engine of choice and type in 1, 2, or 3 words, and they're kind of guessing what would give them the right results. And then there are other people who are going to say be a bit more structured, so they might use some of Google's features like doing site colon search within a site and specific things, and various different levels of expertise, we're saying, in using Google. And then there's very different intent. So let's say somebody puts in like cheap hotel, London, for example. They could be doing very different things. So how do you overcome balancing that as, what did the human mean and what's a good human judge going to do for that versus whether the LLM or the kind of question answering system? How do you account for that in studying it?
Let's say it's messy. I think it just introduces a bunch of noise. Okay, I should full disclosure. Like this is me being the machine learner. There's some people in my domain who really study users and users' intents and what's in their users' minds and the whole psychology behind that. I'm not that person. I'm on the other side of the spectrum. My users behave exactly like one of these metrics, like normalized cumulative NDCG, cumulative gain NDCG. This is how my users behave. That's the world that I'm in. And I just like optimize my software to just do that to that user. But also, I mean, at the same time, I'm also like a human being. And I'm like, well, I'm not that user. And clearly we need people to study that. So I don't want to go into detail because it's not my area of expertise. But number one, yes, the variety of things is a problem. I also say, it's not okay for a search engine to just refuse to give you a result. Like, I mean, it's just sort of like if I want to know about cheap hotels, I don't want to have this search engine lecturing me that cheap hotels are bad and the staff needs to have better pay or something, right? This is just like, I'm sorry, you are my tool. And I hope you're not offended, but like you are paid or not paid in ads, to do that job. You have to do the job and be helpful to me. Otherwise, this is like, this is a service economy of systems, of information systems, right? But the reason why Google is hiring so many people to do the annotations, because yeah, they try to like cover a whole range of different information needs, from the short ones to the long ones, to stream of consciousness ones, to queries with typos and so on and so forth. So
Yeah.
it's hard.
And the reason I like the example of cheap hotels is cheap is very much context dependent. So if you're a billionaire, a cheap hotel is maybe several $1,000s a night. If you're stone cold broke, a cheap hotel is, youth hostel at $15 a night. And there's everything in between. So it's very context specific that isn't there in what somebody typed in. So I found that very interesting from the bits of machine learning I've done, in that actually people say, we want this to be 99% accurate. And I've come back and said, well, how do you define that? I've been trying to apply it very simple things and trying to explain to people that, you can't have things like that are deterministic that are going to give you anywhere close to 100% accuracy, because there's often context missing, there's often details missing, and we can't properly define what it looks like.
So for a long time, people in the community purposefully studied underspecified information needs. Here's a famous example is Java, the coffee, the programming language, the island, and I don't know, probably a whole bunch of different shops have that name too. If somebody puts in the word Java, like what do they mean? And how can we still, I mean, we can come back to them and lecture them, like you need to be more specific, but I think that's like not really appropriate for a search engine to do. Instead, how can we maybe hedge our bets in showing them some search results of, did you mean more like coffee? Like, did you like this or this or this programming? Or like, and someone like Google started like this, did you mean question? Did you mean the coffee? Did you mean the band? But it's it was recognized as like a thing, and especially when you have like the fewer words you use, the more ambiguous your request becomes, right? But that's separate from the other question that you point up, like what does quality even mean? And sometimes, and this is like both depending on the user. Like I like a short response, other people like these long responses. Sometimes you're in a situation where you don't, especially when you are interested in a topic and you don't know much about the topic, where you just want to just give me an overview. So I want to have a longer response. Sometimes I really want to know what kind of window would go into a this by this hole. What's the number that I need to put in the search engine to buy the right kind of window to fit my house? It's a very, very specific kind of thing. And sometimes it's just like, also like who you are. Like if you're retrieving for like a 5-year-old child, you probably want other documents than if you retrieve for, I don't know, a grown up or somebody who's like a nuclear physicist or something. There's sort of like, there's a spectrum of like also what is an answer that is appropriate for you. And that needs to fit into with quality. And I think that's something that now kind of like we are actually able to even study. Like, 5 years ago, that was completely out of reach. Nowadays, it's like, okay, so we have a user background or we have a user profile. We have a longer description of what they want. Maybe we have a short topic. How could we use that to really identify, well, what is it? What is an appropriate response to a user with that background that has this kind of problem? And and I think, and these are like really interesting questions to ask. But now, when we say LLM as a judge, is this relevant? Yes, no. Relevant, yes. It's not that easy, right? It's kind of like, it's like when you go to your coding AI agent, you say you put in a specification and then it comes stuff out and you're like, well, is this relevant? Is this good? Well, it depends. It's like, does it run? Is it correct? Is it correct in all cases? Can it read the user's mind? Are there some small bugs that maybe you don't see at first? This is like, I mean, again, this is why I said, it's which application you're trying to judge for. Like I come from information systems, but you can also look at it from a lens of code AI. It's like it's also like your little code AI. It's another information system. It's just like I say, hey, I want to build that thing, and it retrieves you the kind of code that comes out of it. And how do we know whether it's actually good?
So I'm immediately, when you're talking about LLM as a judge before, jump to code review. As we look at using LLMs to produce code review is looking like the next big problem. How do we judge all this code that we've got out of an LLM? And LLM as a judge, and does LLM as a judge provide options for this? But as you're talking about it, I'm sat there thinking, we have to define what good code looks like. I think we're going to struggle there. I think that's something that we don't have agreement on. And again, it's probably going to need so much of that context, like cheap. Good is one of those perspective of things. What's good? Is it good because we shipped it quickly because we need an MVP out? Is it good because it's going into a nuclear power plant and we want it safety critical and it must absolutely never fail, or it must fail safely? I think that's going to be incredibly hard to approach. So you said you're a skeptic. What are the challenges that exist that you see that potentially need to be overcome to make this work, or potentially mean that it won't work?
Are you talking about in the kind of information system world or in the code world? I think these are like, there are some connections and some differences too.
Let's tackle both, because I think that will give us perspective on both sides. And a lot of what we do when we're building software is information retrieval. I mean, we sometimes software engineers are mocked because they just build CRUD systems, but mostly what we're doing is we're pushing data around the world. That's generally what we're doing with computer systems.
Yeah. So I mean, let me maybe start in the domain I'm most comfortable with, and then let's stretch our feelers. So like let me pick an example application that is something I've been working on for a while, and initially that was like 10 years ago when summarization wasn't really working very well. I want to build something like a Wikipedia article for my own search request. Let's say I want to say, I don't know, snow melt after a big snowstorm, and how does road salt affect that? And is road salt suspended in the air or something like that? So it's kind of a little bit fuzzy, but you can imagine somebody could write a Wikipedia article on that topic. You just need to like find a better title. Can we train ourselves to retrieve documents from the internet and compress them into writing an article for Wikipedia? We can learn from other Wikipedia articles how to do the retrieval and how to do the summarization, and we can transfer this one to a new domain. But now we want to know, well, this article that we just generated, we trained it with Wikipedia articles. Is this good? So we can do two things. Like if we just live in the world of like, retrieving things and not generating things, we could like take an old Wikipedia article, can take it apart, can say, hey, did you retrieve the things that were originally on that Wikipedia article that existed? And we can use that sort of as a means for optimization. So now, but when we generate things get difficult because every time we hit generation, especially with a probabilistic model or probabilistic LLM in the background, we get a different response every time. Okay, so this is also the other reason why we are so excited about LLM as a judge, because previously we couldn't really evaluate things that change all the time. They're not reproducible. So now the problem, like a couple of problems, is we want to use an LLM to say this, whether this is relevant or not. But we also nowadays want to use an LLM to produce the result. So that's kind of like, imagine you would have a fifth grader both writing an essay and then grading its own essay at the same time. Oh, do you think somebody would get some A's? Right? I mean, and I don't see why should it be different with LLMs, right? I mean, like I often say, when people are saying, "Oh yeah, we just use LLM as a judge for everything. We don't have any more humans even looking at it," and I'm like, well, that's a little bit trusting. It's like, are you a faith-based engineer or something? You just hope that the system trusts. It's like, well, no, but we have an LLM. We know the LLM works. And I was like, well, if you already know that your LLM works, then the LLM that built your system, your system is going to be perfect because your system is using an LLM. And as you just said, the LLM is perfect. The LLM will not make mistakes. And I was like, no, but we need to evaluate because clearly the LLM makes mistakes. And I was like, well, but if that LLM makes mistakes, and this is the same LLM that will also make mistakes. So how do you actually now know whether you measured anything? And people usually say, oh, but the numbers are really good, and this is why we like to use it. And I'm like, if you want numbers, I can give you numbers. The temperature on Mars, how many specks of dust do you have on a telescope lens? These are all numbers. I can give them to you. You can pick the ones that you like, but that doesn't mean that you learn anything from that you wanted to learn. I mean, this comes back to, do you want to know whether your system actually works, or do you just want your system to look good in some of the official benchmarks? I might be a little snarky, but I also wouldn't hold it against a business to just want to look good in the benchmarks, because this is where your business is coming from.
Yes.
And this process, I mean, it's often called circularity. It's like you use the same thing to both generate something and to judge something. And I think if you move to code AI, it's the same thing, right? We want to use our code AI to like help us write our code, but then we have to review the code, which I would argue is a much harder problem to review code written by somebody else than just write your own code. So we don't want to do that because it's even harder. So you want to use an LLM to use code review as well. So you're in the same situation. We have one LLM to generate the code, and then maybe next thing we want to do is use the next LLM to judge whether the code's actually good. It's like same thing. Maybe you're going to get some A's. Maybe you're going to get some great numbers out that maybe make some people look good and sell their product. But we can't really find out whether it's actually good or not.
I think part of the problem for me for code review is defining what good means for code review. As we joke about it a little bit as a meme in software engineering, that if you give somebody 5 lines of code to review, they'll find 20 issues. Give people 500 lines of code to review, you'll get, looks good to me. So I think defining good is quite hard. One of the things I've always felt as potentially useful from LLMs as a code review is they don't get bored. They don't look at 500 or 5,000 lines of code and say, I can't be bothered, LGTM. Whether you give them 5 lines, 5,000, 5 million lines of code, they're going to process it and they're going to do it a lot faster than a human would. So if they only catch 10% of the issues, is that better than if we hadn't used an LLM? So from that point of view, I sometimes feel that they can be useful. Whether or not we can count that as accurate or just less bad than a human said looks good to me, very debatable, I think.
Right. I think I'm not disputing that there is some value in using LLMs on either side of these processes. I think maybe my question is, how can we bring in a human into this process and make the whole task a little bit more humane? And with humane, I mean, can we design a task where a human still is integrated, but is used in a maybe more effective way, or in a way that's more natural for a human than the mind-numbing combing through every single line or something? Okay, so there are typically like two major approaches. One is you let an LLM produce a suggestion, and then a human checks the suggestion. It turns out there's actually some really depressing results, like more from a psychology angle, that humans are bad at doing it this way. If you show a human something as a suggestion, they probably say LGTM on the proposal. So you get the same thing there, right? So, but maybe there's some way where you want to have a human first look at something, and maybe you can guide a human in a way that it doesn't feel quite like a proposal, but some way where you maybe get them to see what the issue is. I mean, for example, like one of these coding tools where you have unit tests, and it like highlights different sections of the code that shows what's whether it's covered by a unit test or not. You can imagine a tool like that. Just maybe look over here. There's maybe something going on. Either it's not well covered, or there's like something else, or like the AI just maybe says this seems to be like a more tricky piece of code. Maybe ignore the other 4,000 lines of code, but like look here, because we think here is kind of like where the rubber meets the road, and we really need to have a close look there. And that would be, I think that would be valuable, because you don't need to crawl through the different spider through your code in going through all the like not so critical pieces of code, but like really start focusing at the part that's really critical. So I think I could imagine like a better, I call it like human AI co-judging kind of like approach. Unfortunately, at the moment, we're kind of going between using full LM as a judge, no human involved, and using just mostly humans, because we don't know how to incorporate an LLM without biasing the human or without falling for some circularity kind of trap. And I think, and I'm hopeful that we kind of like have a better means. It's just, it would help if we finally strip ourselves from this like false dichotomy of saying full LLM as a judge, and we drank the Kool-Aid with two straws, and the complete skeptic camp that says, well, obviously something is really fishy and we can't trust anything, and we just have to just do human do everything from first principles. Like once we strip ourselves from the false dichotomy and see, well, there's a middle ground, and really are also like sincere in studying this middle ground, and not just like peddling I thought about it for 5 minutes, I built a system, hey, buy my system and look, it works and it makes me look good at my statistics. If we really kind of like focus on this middle path, I think we are kind of like, I trust innovation and the creativity of minds enough that we find something, and that's both a problem in the more information system area, as well as like in the code AI kind of area. Like not just go full one end or the other end, but like how can we build processes that plays to both strength and not to both weaknesses?
So slightly different approach, but as you mentioned that, I was thinking that Netflix offered $1 million prize, I want to say about 15 years ago, for a recommendation system.
I remember this, yeah.
And if I remember rightly, the winning entry did a mixture of systems, and it combined and aggregated them.
This is always, you have a great idea and then you ensemble it with some other great ideas, you get even better ideas. This is of course how you engineer such machine learning systems. Yeah.
Great. So is that being used in LLM as a judge? Are we pulling together multiple LLMs with different structures and creating an ensemble? And what does that typically look like?
The same way. Yeah. I mean, you just take a bunch of good ideas and then you ensemble them together. You learn how much weight to put on each of them. As a fun story, like a year and a half ago, there was a competition around like LLM as a judge, and students and I were like, whoa, we are so participating in this. And it turned out like she actually got the best system according to one of those metrics. You're like, awesome, we won. And we won with a pretty simple LLM and with a kind of like not a too complicated approach. And we like landed there. And everybody else did complicated things, and we're like, how did they do that? I don't know. And this is what I like about the friendly competitions. It's like, how did they do it? And now you get really curious, and it's like, I want to understand, right? Or I want to understand why this thing that we all thought would work did not work. Other kind of great questions. Anyway, I think they did this a couple of more times. We didn't participate, but ultimately somebody was able to dethrone my student with a system that used multiple big, I would call them prescription strength LLMs and different approaches and ensemble, and they got this much better. I was like, well, how much is this improvement worth it to you in terms of cost and water use, energy use? I mean, it's like, LLMs, it's not that they're like cheap technology, it's like, the bigger systems is kind of like, I cannot even run them. I mean, I have pretty good servers at my university, but I got like bought out. It's just like, I can't afford this. I mean, I think around Christmas, I said, after burning a pole cap melting amount of tokens with some code AI tools, I kind of like, I've landed here. I was like, yeah, it's like, we just don't really think about it. We're just like, why does this take so long? Getting, you wait for your code AI, you're drinking coffee. It's like, can we just like accelerate this? It's like, yeah, there's like a lot of like compute that goes into this. And I think we also like need to like focus on how can we get the computation cost down without losing quality, right? This is like the other side of this. Yeah.
Yeah, that's going to be I think, a very interesting and a very big challenge, because as we reduce that cost to compute, people are going to try and do more with it, which is going to increase the demand and increase the size of models that people want to try and increase their expectations for latency.
But I think people would want to do more with it anyways. I mean, like anybody who has a curious mind and says, oh, I have this hammer now. A hammer puts nails in really well. What else can I do with it? I mean, this I think is sort of like an engineering mindset is I stumbled upon this thing. It seems to work here. What else can I hit with it? And I think of this as a good thing, even though it comes as like an energy cost. But like I think people would want to do more with it. How much it costs, it's so secondary. At some point, people spend half of our salaries on like things just because we are so curious and because we think, hey, this is kind of working. It keeps me going. So I think getting the cost down is just going to be good for the planet and for the commons as well. To avoid some tragedies.
Yes, it will be interesting to see if they can get the cost down before they run out of VC money as well for these big models.
Yeah, it's true.
I think I saw something today. Saying that it's costing OpenAI something like 3 times what they make just to run the inference.
I think I think in general we live in an economy where the price is not dictated by how much it costs to make something, but by how much are people willing to pay for it. And it's sort of like, this decoupling of cost and price. And I think with LLMs, that's kind of been, strong. And I mean, like, it's like, how much VC money do you have to like subsidize this to get everybody else out of your competition? That then at some point you will be the only business standing that can do something. This is not a great way to measure quality, by the way, but like, here we are, right? And I don't hold it against the business to try to maximize their survival chances.
Yeah.
But I think, bringing the cost down, I think it's such like an essential problem that I think people are working on it. And I think somebody will at some point be successful with that.
Absolutely. So the thing that's occurred to me recently, looking at some of these models as we talk about that, is that there doesn't appear to be much difference between whether you go OpenAI, Anthropic, Gemini, or some of the big open source models. For a lot of people, the quality is indistinguishable. They can substitute one for another. Yeah, so that was my question coming for you is, when you're looking at this LLM as a judge, are you noticing that a model that you could run on your servers at university is significantly worse than one of the state-of-the-art frontier labs? Are you noticing a difference between the different frontier labs? I won't get you to name any and call them out or whatever, but are you noticing that there is a significant difference? Or are they largely comparable when you're coming to use them for that?
Well, I think they're like different generations of LLMs. Okay. And, a model that came out like 6 years ago is of course not as strong as a model that came out yesterday, right? I mean, there's been progress. I mean, some of the progress has been bigger is better, but I also think I think that's too simplistic. I think there have been like progress on foundation models and the architecture between your like rope and different forms of attention and so on and so forth, which really also make the model more conducive to learning, and also kind of like maybe to some extent also like more efficient to learning, right? There's kind of like a how do you squeeze the most out of your training data. But I think, of course, with LLM as a judge and like our meta evaluation on LLM as a judge, we can see performance differences between using different LLMs on the system side and different LLMs on the judge side. And, but it's kind of like it goes like, yay. I mean, I think there's still like which prompt you're using or which prompt template you're using for which LLM matters a lot. Because, when an LLM is trained with a particular kind of way, it does really well if you use it exactly this kind of way. Now, that often is not really well articulated, but like there are people who have an inside scoop. And if I use your framework and I know you have the inside scoop of how the LLM was trained, I would probably assume that, well, that's probably the secret sauce in like how to use it. I mean, for example, if you use an LLM with multiple outputs at the same time, like I want both a passage highlighted and a grade and something else from one prompt. Now, how can I parse this output? If I put things in like I have to kind of communicate, I want 3 outputs, I want 3 things. How do I communicate this? And this is like where you see, it's very obvious, like where, if you use the right way of phrasing this, like, do I put things in a JSON envelope? Like I want 3 things, 1 thing, 2 things, 3 things, colon, fill in here. Or am I going to use some like a bunch of like hashes and saying pound, 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 1 variable, pound, 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 next variable, kind of like, how do I phrase this to an LLM? And that makes a real difference. And you also see how many of my LLM responses can I parse in a certain envelope. You see kind of like the difference. We were kind of, in my household, we have our own pet LLMs. So we were playing around with some of the quantization models and we quantized the model the wrong way. And we realized it still superficially looked good. It could speak English, even though we quantized it the wrong way. But what it couldn't do, it couldn't produce the right kind of like output envelope. So I couldn't parse the responses. It was the first thing how we knew the brain damage of the system that we caused by just quantizing it the wrong way. So that's kind of, I mean, that tells you 2 things. Number one, it tells you how bad humans are in identifying a better model from a worse model just by looking at the English that it produces. Number 2, a model can be pretty wrong and still be like mostly useful. It can limp along. It also just like says, well, maybe the easiest way to see a difference between models is by doing some structured output task. Like, can you produce the right JSON envelope if I ask you to produce JSON envelope of a certain kind? And that seems to be like a better test for LLMs than just a human just looking at the outputs. I also think like many humans just can't really judge quality. Sometimes you go to your favorite like interactive LLM and they occasionally pop up 2 answers and they say, tell me which one is better. But the answers are, well, they both are somewhat on topic. The information is kind of rearranged. So it's like, I cannot tell which one is better. That doesn't mean that there is no performance difference. It's just like the way it's presented to me, I cannot tell the difference. So I think this is like where, as long as you use like a latest big model, I think you probably have a pretty good model. A lot of like the performance differences will be in how is it being prompted, how is the template, and is the template well aligned with the LLM. So when you have like, software vendors that sell you both a software tool like a AI agent along with their custom-made LLM, I would probably think they probably know how to get the most out of their LLM by just asking it things the right way. That's probably that's how I will be doing it. And this is, I think, where the next business of LLM companies will be in, that they sell you not just an LLM that you can query via a web interface, but actually an LLM that is designed to work in a certain API and a certain kind of like interface way, which is also kind of like, I mean, it seems from an engineering perspective just the right thing to do. Are these models different? Yeah, I mean, they are different. They're all trained on the same kind of training data. The only way in which training data is now differing between different models is with what they learn from the users to interact with them on their web interfaces. And this is kind of like something that we've seen with web search engines 20, 25 years ago. What made a web search engine really good, like what made Google really good, is that they had more users. So from the users, they learned more about, number one, what are people currently interested in, but also what do they think is correct. Like if you ask the same query that a million people asked before, you just follow the footprints of the sheep herd, right? It's like, it's pretty easy to get you good results if you have other users essentially annotating the right documents for you. So we kind of like see the same thing with, interactive AI products, like your chat agents. What puts them apart is how many users use them. So they have more training data, more updated training data to kind of build a better LLM. And we will see the same thing with like code AI. Whoever wins the code AI race, arms race, gonna get more users, gonna get more training data, is gonna have a better product.
On that note, then, do you think there is a limit to where we can go with the current scaling, given that they've kind of sucked in all of the internet, they've pulled in a lot of the material that they can? We aren't producing code that fast relative to the whole scale of amount of data in the world. It strikes me that we're coming to diminishing returns.
Yeah,
and
I think
maybe there's a limit to scale.
We're definitely at like peak training data. People were saying that, Stack Overflow, which was like, go-to resource for like 2 decades or something. Now nobody really uses it because people directly use their code AI. So I read all of like Stack Overflow, which means nobody has any incentive to ask any questions on Stack Overflow. And certainly nobody has any incentive to answer anything on Stack Overflow. Like, are we kind of like stuck? Is that it? Are we at peak knowledge? Like if users have no incentive of providing like new knowledge, and you say, well, I'm just going to use my AI for everything. Well, the AI, what are the AIs going to learn from? I don't know. I mean,
even worse, they're going to learn from AI generated content. Then potentially we get into poisoning.
Yes. I mean, this is like where I think maybe we are like at peak knowledge or at peak training data. And now that's sort of like a famous kind of like machine learning paradigm that gets like reinvented every time. It's called bootstrapping. And then very soon after that, people discover concept drift. What does bootstrapping mean? Bootstrapping means, for example, if I have a classifier and I train the classifier with training data, and then I apply the classifier on more unlabeled data and sort of label it, and I use these labels to train a new classifier, and I keep on rinse and repeating, that's called bootstrapping. And it's sort of like it comes back in all kinds of flavors. Typically, it might work if you do it once, but if you keep on doing it, at some point, the errors that are in your original classifier are kind of like compounding, and your results go whoop, kind of thing, right? And it's the same thing with LLM as a judge. You can use a system, you can use LLM as a judge once, but if you kind of like use the LLM as a judge to actually give a reward signal, post-training, everybody, like I would not expect that to be a use to lead to salvation. It's like it works one step, maybe 2 steps, and it's someone.
What about then so there's always two sides of machine learning, isn't there? There's, can you get more good quality training data, and can you build a bigger model? So if we reach peak data, can we build a bigger model without just overfitting?
I think there's a third approach, that is to build to use a smarter idea. I think having big training data and having big models, I understand that's sort of like an easy way to do. But I mean, I made a career by just doing something in a different way, or just say at least maybe keep an open mind to doing something in a different way. And you often stumble upon something like what we did with the exam answerability metric of, oh, we did not really think that we could use this other thing, but oh, look, this was like a lot cheaper to write. It's a lot cheaper to write multiple choice question than to label 1,000 documents, right? So we have a different way of handling this, right? Or can we reorganize how we do work in bringing in a human in a humane way, and using an LLM in a way to just help the human just like be faster and be also like more focused, right? And I think that's what I'm saying. I think that this is a false dichotomy. It's not just about more training data and more scale. I think at the moment, honestly, most LLMs actually have too many parameters. I mean, they have so many parameters. We don't even have that many concepts to even discuss. So there's probably a lot of like compressibility in these models. And there's another kind of like very foundational like idea in machine learning, that is, if you just have the right number of parameters, so you have just compression enough so you generalize well, but you also have enough flexibility so you can express complex things really well. So like the size of the hypothesis space, if that one is just right, you probably get the best machine learning. At the moment, we are out there. So I think if we can compress our models, and if we can also design the models to be just right, we could probably do a lot better with the training data that we currently have and probably fewer parameters. So I think we are not at the end of it. The limiting factor right now is compute, and how compute, like especially training a foundation model, there are very few people on the planet that can do that. And we should make sure that some of them are in this country or in your country, and not put them out of business, because getting up to that point where you are in a situation where you can even train a foundation model, it's going to be, it takes time, and it's going to take hardware to do that. And it also takes people being experts in doing that. Unfortunately, so this is sort of like currently like our bottleneck. We'll see.
So if I paraphrase that, then we've reached peak data. We maybe made the models too big, so making them bigger is not necessarily going to be a big leap forward. You think that probably the best way forward is for us to find a different architecture, a different approach. So rather like we had LTSM and then we had the attention mechanism, and that gave us a step forward, finding something else like that.
Yeah, I think, the story of attention, and like attention is all you need, is really one on, we kind of like engineered ourselves into a corner. Why don't we just peel back a whole bunch of technical debt that we accrued? Just use the one thing which kind of like seemed to make a bit of a difference, and just like try, is that thing enough? And that's kind of like what led to the rise of transformers, which now have replaced all other models. So now I think there are problems wrong with the transformer architecture, and especially like how attention is essentially like a weighted sum of input vectors. Like sometimes the sum is the right way, like especially if there's one answer. If you want to kind of cover something that says we want to do, like all relevant things need to be in this one thing. But sometimes the sum is the wrong thing. Sometimes you want to have a product. You want to be very, very specific and saying, no, I don't just want to take any of these bits. I want to identify exactly the part that I should pay attention to. And I want to be very, very selective. And you can do this with multiple different ways. But like, I think the fact that we use like a weighted sum in attention always struck me as maybe ideal for some cases, but not really ideal for other cases, especially coming from the information retrieval perspective, where you had some, like for a document to be relevant, there must just be one sentence in a document that's relevant. That makes a document relevant and like worthy to retrieve. This is not the right thing if you want to present it to a user. A user wants to have just the relevant stuff like pulled out. So there's kind of sometimes you want to have everything must be relevant for an answer to be relevant. Sometimes you just want to have any piece of it must be relevant for this thing to be relevant, depending on where you are on your pipeline. So that's kind of like where you want to have a mixture of ands and ors. In probability, there are like noisy ands and noisy or. A noisy or is a sum. A noisy and is a product. So you want to maybe sometimes like shift between the two, or you want to have like more options. But like currently we are still kind of like locked in with, hey, transformers were the first thing that really worked and like supersede everything else. So clearly the weighted sum must be the right kind of thing. And I'm like, maybe it's not. But like, I wouldn't be able to just like try out a new foundation model because it's just way too expensive to run. You can also like only do this so often.
So almost then we want to learn not just the attention mechanism, but what is the right attention mechanism for the particular phrase we're dealing with.
Yeah, maybe that's... and if you follow like some of the blogs, I mean, there is like, we have like all the different ways, I mean, between different attention mechanisms, we have like different mixture of experts mechanisms, there is a variety. It's just like that the number of actors that can actually do something with them are like limited. At some point you have to like place a bet on where am I gonna spend the next $10 million on training a model.
And it's hard to place that bet. It's hard to place a bet of that size that's not on the obvious path.
Correct. So if I had infinite amount of money and like infinite cooling and infinite energy, like the problem would be very easy. We just try them all, right? And then we pick one, right? But like as an engineer, that's just like it's not really feasible. Okay. But I also think that beyond like just short of training foundation model, there's still like many other things. We just went through like the big phase of like prompt engineering, and before that we went through a big phase of like fine tuning, and that's kind of like and now we are now post training is the next thing. So I think there are like multiple different things to do, what we can do with a pre-trained foundation model. Also like pre-training and post-training. The idea for a long time was where we have the foundation model and we build more layers on top, and more particular learning happens in these layers up there. It kind of got like superseded by prompting, also because what came out of the last layer wasn't really like too big, so most people couldn't really handle it. But for the last 2 years, I mean, I've been saying, I'm a computer scientist. I'm not an English major. I don't want my job to be crafting the next prompt and like finding the magic incantation, because we all know magic comes at a price. I don't want to pay the price. I want to be an engineer.
So we should wrap this up, because I've taken an hour of your time. So thank you very much for that. What do you feel about in-context learning then? There's a lot of misunderstanding, I say, about LLMs. People think that they are intelligent and learn. The counterpoint being that after we train them, they don't learn anything more. But then we've got this idea of in-context learning. So I think there's a lot of misunderstanding about all of that. Can you maybe kind of clarify that for people, please?
Well, there are multiple things to unpack here. I mean, one thing that you said is people think that they're intelligent, right? I think, yeah, a couple of years ago, somebody put out a tweet when it was still tweets saying, if you just replace AI with matrix multiplication, which is ultimately what it is, would you say matrix multiplication has become sentient? Like matrix multiplication, right? So what is the thing that's being intelligent? At the same time, I've been working in groups that had the name intelligent in the name, the Center for Intelligent Information Retrieval, and like other kind of thing. What we want is systems that appear to be intelligent, right? We want to, I mean, same thing with machine learning. We want you to do the task, but you want you to do the task intelligently. Like, we don't want you to do the task in a dumb way, right? But I think what's important is it's sort of like the appearance of being intelligent. And I think it also says a lot about, I think there will be lots of psychology theses being written about how easy humans are to be taken advantage of. Think about the existence of magic tricks. The fact that we have magic shows is just a sign of how easy we are to be. We're so gullible. Our brains are just gullible, right? I can show you two things, and like maybe one text is like watermarked or something. We will not be able to see it. We're completely blind to that. There's like a little.
Eliza was a great example of that, wasn't it? There's some very simple psychological tricks to make it look as though there's something intelligent, but it was just a clever choice of words, and you can build Eliza on about 600 lines of code.
Yeah.
There's no intelligence there.
But then at the same time, it also like, it doesn't like, I don't know. I'm also like not a neuroscientist. I don't know how to even define intelligence in the right kind of way. But I'm just saying, I find it more helpful to think in terms of usefulness. We have a thing that's useful. We can also have a coworker who is useful, and we have another coworker that's less useful. Okay. I wouldn't call them less intelligent. I would just say, well, you're less useful. And that's kind of something that's a little bit more measurable than intelligence that I have trouble even defining. So now if we just stop using the word intelligent, smart, and so on and so forth, and we just replace all these words with useful, like artificial usefulness. Now we're talking, right? Is code AI, is it useful? Yeah, it's useful, right? Is there some use in it? I mean, can it do everything? Probably not. But is it useful for some things? Absolutely yes. Right? I mean, this is the thing of like, why I say I'm not like not an LLM as a judge skeptic. I'm not saying that using the idea of using LLM for some form of like being involved in the judging process is bad, right? Like, no, it absolutely is kind of like, it frees the human mind to stop being distracted from the little things, from the little mud that we have to wade through to actually get to the stuff that we actually want to do. We lose our train of thought. If we have a chat, like an LLM agent that kind of helps us to keep our train of thought, because we can think ahead and kind of build our complex system, because we have somebody that takes care of routing a variable through the right way, writing a command line interface, and so on and so forth. That's great, because it's sort of like, for the people of us that are like easy to be nerd sniped and distracted, this is really helpful, artificial usefulness to just keep me thinking. But I think, ultimately, but if we if we completely cut out the human out of the product, we kind of like land at where Stack Overflow is right now, where you don't have any more training data. You don't have any more discourse. It's not even, what's the point in talking to another human about my coding problems if I can just use AI? But now if I use AI, well, the saying that whoever is building these kind of tools and give them to you for free, they kind of collect your training data. Like, it's not, I wouldn't call it like, surveillance or anything, but it's just, it makes sense that they just keep track of how often did I say no to my code agent, and like, oh, maybe there's a signal I can learn from.
Yeah, just like as we say, the search engines did with the search results. How often do you click the first or the second or third? That gave them feedback on how good the results were.
Right, and also like it was also for the benefit of everybody, because search engines learning from that made the search engine arguably better. I could find the things with like fewer kind of like query reformulations. And the same way with coding, I will be able to code without having to like dance around, do handstands, and kind of break things down for my code AI agent, because somehow a million sheep kind of like helped create enough training data to help train a better LLM that led to a better code agent, right? So this is kind of like, the inverse tragedy of the commons. It's like, and this also comes back to, computer supported cooperative work system. A system is only as valuable as many users are using it. I mean, this is sort of like the opposite of antitrust. It's kind of like saying, well, no, you want to ideally have one platform that everybody is on, because now that platform becomes most useful to everybody. At the same time, we don't just want to have one business controlling everything, because then no other system could ever build up anything, because they don't have the training data, because training data is locked in here. I don't know. I think these are both exciting times and terrifying times at the same time. It's like, I just hope that we come out the other end unscathed, and maybe having more creativity flowing. I mean, I think, I was talking to colleagues in the engineering department who are using code AI tools with their students, because they don't really have a lot of training in coding. I said, oh, but like, when does the house of cards come crashing down on them? Just keep an eye on that. But on the other hand, it like gets a lot of people like excited about coding that were not excited, were just terrified of coding beforehand. And I think that's a good thing, because, I think I always liked sculpting things in code. I think it's my means of expressing my ideas. And I find it sad if like people kind of feel like left out of this. I think everybody can code, and everybody should at least try to think about it. Like, everybody who can follow a recipe in cooking should also be able to code. This is like it's the same kind of like idea. You just, maybe if you're more creative as a cook, not just following a recipe, but like combining different recipes, right? This is the same thing as like coding. So if this whole code AI thing gets like more people to just like who are not traditionally like completely not even thinking about trying it, if they get it to like try it, I think that's a good outcome. It's like it's a means to of creative expression, and I think it can also be liberating. Like that's it. I run my own LLM. I'm currently working on getting my own retrieval augmented generation system just to use in my own household. I think that's amazing. It's just like, use your own stuff.
Yeah, I think that's the tension as well, though, for software engineers, isn't it? Because it is amazing, and that creativity is what drew a lot of us to software engineering. I mean, I started building computer games because I was interested in how computer games were the way of expressing that and being creative. Having your LLM generate the code, for some people, I think takes away that creative element, because writing the code was that element. For me, I don't feel it as much, because now my creative element has been, I have built something that does something. So whether I wrote the code or whether I did the architecture and did the requirements, I don't mind, because I built the thing, I got the outcome. But for a lot of people, it is that craft and it's that creativity, and it's a bit like creative writing. I want to produce a book. Some people want to sit in front of the typewriter and write the book.
But you have the choice, right? I mean, like as an engineer, and I think it is worthwhile to double check the code that comes out of code AI and just look at it and saying, this is not good design. Let me rebuild this thing. And you can either build it by kind of like giving your code AI agent like more micro instructions to saying, or just like also like, fighting back. I mean, my code AI agent here is like, no, probably about like 40% of the time. I'm like, no, this is not good enough. I'm sorry, this does not meet the bar. You have to do better than this. Like, you're doing this and this and this wrong. I'm probably the best source of training data for code AI at this point, just because I say no all the time. But I think this is also an element of being picky. There was like this personality test. I think like I heard, and I don't know whether it's true, that some HR in an interview asked, hey, open your chat GPT or like your other AI agent and just put in, what is the main character flaws of me, ? And see what comes out. So I was just like curious what my code AI agent would say about me. And I said, you're very nitpicky, you're very opinionated, but that's good because you don't let bullshit like go through. And I was like, yeah, it makes sense that my AI thinks of me like that. I think my students don't think I'm quite that harsh. At least I hope. Students, hi there, send me an email saying that it's true or not. But but I think maybe that's also something of maybe another machine learning mantra is your machine learning works better when you have a very nitpicky training objective and also very nitpicky training data. Like you don't want to give lots of extra like half credit and so on in your training data. It doesn't help your machine learning. So machine learning needs a strong hand, even though your human children maybe needs some more compassion.
Well, that's been a great talk. Thank you, Laura. It's been an absolute pleasure. I've taken over an hour of your time now, so thank you very much for that. It's been a lot of fun. If anyone wants to reach out and talk to you about LLM as a judge or maybe become a student in future, how can they best contact you? And we'll put the links in the show notes.
Sure. The best thing to contact me is via my university homepage. That's like via the University of New Hampshire. If you search for University of New Hampshire and Laura Dietz, Dietz, you probably find me. There are a few Laura Dietzes. If you find one that talks about psychology, that's not me. So but I think I'm pretty easy to find. You also find me on social media. I'm always happy to like chat with people in like any capacity. As a researcher, we always like to talk about like our favorite pet subject and some adjacent subjects as well. I always like to hear from you. If you have any crazy thought, if you want to push back on anything I said, very happy to hear about this. You know, I'm like, I have zero problem being criticized. And sometimes I'm just wrong. Maybe you should do this again in 5 years and you like say, Laura, you said this, this, and this. Do you have anything to say to your former self, right? And I might say, oh, okay, I was wrong here, but I was right here.
Well,
oftentimes I'm
that's the best way to be, isn't it?
At least I'm sometimes right.
But that's how you have to be if you're going to research, isn't it? You know, you've got to have a hypothesis and be prepared to be wrong and be prepared to learn, and that's how we advance the field, isn't it?
That's right.
All right, awesome. We'll put the links to your homepage and LinkedIn and any other socials you want to send us in the show notes. Thank you very much, Laura. It's been an absolute pleasure.
Thank you.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.